Roots and radical expressions. So first let's identify a few terms. This square root symbol is actually called the radical sign. The number that's underneath that radical sign is called the radicand, and then the number that sits right here in that radical is called the index. When we've worked with radicals before, we've taken the square root, and the square root actually has an invisible 2 sitting right there. And that 2 tells us that any number multiplied by itself, when we take that square root, it's equal to a. And then we've worked with the cube root recently, so if you have a number multiplied by itself 3 times, that is the cube root of a number. So we're going to take that same idea with any other index. If you have an index of 4, that means you need a number multiplied by itself 4 times for it to be the 4th root of it. And then if an index is 5, a number multiplied by itself 5 times will give you the 5th root of it, so on and so forth. So let's do a little bit of practice. So let's go ahead and find the real root. We're going to start by simplifying this the way that we know how. 81 is equal to 9 times 9. And then we're going to keep breaking this down. 9 is equal to 3 times 3. And then this 9 is equal to 3 times 3. Now, once you've simplified your radicand into primes, the idea before, when we were taking the square root, you had to pair numbers up. But now the index tells you how many need to make a group so that they can escape from under the radical. So we need a group of 4. So here we have 4 3s, so they're going to group together, and then they're going to escape as 1 3. And this is actually the real root. Whenever you have an odd index and a negative number underneath the radical, go ahead and pull out that negative sign, and then we're going to go ahead and simplify this the way we know how. 8 is equal to 2 times 4, and then if we break this down again, the 2 comes down, and 4 is equal to 2 times 2. So now we can group together this group of 3 2's, because our index is 3, and then we're going to pull that out, and that's going to be negative 2 is our real root. So in example 3, we have an odd index, and we have a negative number under the radical. So again, let's go ahead and pull that out. We have the cube root of 8 over 125. Now remember, when you have fractions underneath the radical, you can actually separate those. So we can put the 8 underneath the cube root, and we can put the 125 underneath the cube root, and we can treat those separately. So 8 is equal to 2 times 2 times 2. And then 125 is equal to 5 times 5 times 5. So when you group these 3's together, we actually have negative 2 over 5 is our real root. Here we want to simplify the following radical expressions, but this time we're going to have variables. So remember, in example 1, the square root, this has an invisible index of 2. And the way we're going to do this is take the square root of each term. So the square root of 16 is 4. Now when we're working with variables, this is an easy way to think about it. X we have to the third, so you want to take that 3 and then you want to divide this by 2. 2 goes into 3 once with the remainder of 1. So this 1 is what's going to come out. 1x is going to come out, but 1x needs to remain under the radical because it didn't have a buddy. Y to the 8th, you're going to take that 8 and divide it by 2, and then we get 4 with a remainder of 0. So since they all get out, we're going to have y to the 4th that make it out. And then z to the 15th, again, we'll take 15, divide it by 2, and we're going to get 7 with the remainder of 1. So again, 7 of them, 7 pairs will make it out, and then 1 of them needs to stay underneath. And this is going to be our simplified expression. So let's go ahead and try that with example 2 as well, except this time our index is 3. So remember, that negative whenever we have an odd index is going to come out automatically. And then the cube root of 64 is 4. A has an exponent of 1. So remember that 1, when you divide it by the index 3, it's actually 0 with the remainder of 1. So he's just going to stay inside the radical. B to the 15th, 15 divided by 3 gives us 5 with the remainder of 0. So 5 triplets of B are going to come out, and none are going to stay behind. C to the 8th, 8 divided by the index 3 gives us 2 with a remainder of 2. So 2 triplets of C are going to come out, but 2 are going to be left behind. And then this is our simplified radical expression. That's it for these notes. I'll see you in class for more practice.